Hi there, this is Emmanuel, and then this is the last part of our tutorial on scientific calculator. Although this scientific calculator we may not contain all of the functionalities of true scientific calculator, but you can develop this further. Actually, I just want to give you this as an exercise to do. So, what I'm going to do basically is I will add necessary icons and functionalities to the buttons we created in the previous video, and this will include x squared and x cubed, the square root, and then of course the pi symbol and its functionality. Okay, so to do this, there are a couple of things I want us to understand. Remember, I explained in one of the videos what we call Unicodes. So you can go and download the Unicodes and you can use them, the mathematical Unicodes to be specific. Okay, now for x squared, the way we write x squared may be different here. Let me just show you how we write it. I'm going to go into Microsoft Word. And let me make this a little bit bigger so that you can see what I mean. You probably want to use Century Gothic here. Okay, so the Unicode for the squared itself is U. Remember the way I said we must always write it. You simply just write U, and then put speech mark, backslash, U, 00B2. Now this is the Unicode for square. You understand what I mean by square? Okay, this is what I mean by squared. Supposing if I want to write, let's say, x squared, you remember if we write x2, the 2 appears too big. It doesn't appear, the x squared here doesn't appear as x squared. So to exponentiate this to 2, I will click on that. So that exponentiation, the power there, this is how, this is the Unicode for that. That power you're looking at here, the Unicode for it is that one there. Alright? So for this reason, it simply means that the x, we also have to include the x because it's only the power which represents the Unicode. So to include the x, we need to concatenate x by simply typing speech mark x, speech mark, and then plus. The plus sign does the concatenation. Concatenation means joining two letters or two words together. If you're familiar with programming, you understand what I'm talking about. So the x is that one, and then joining the x, we use the plus. The power is the u there. Now, another thing I want to say here is that if you want to concatenate, let's say you want to write x cubed. To write x cubed, we can do it the same way. Okay, so now we have the code for x cubed, for the cubed, for the power 3 there is just the same way we've done it before. I'm just simply going to type u speech mark backslash u 0000b3. The only difference is the 3 there. So to concatenate x, we simply just type speech marks x speech mark plus. Okay, so this will be x cubed, that will be x squared. I hope this is clear. And for pi, we do it the same way. Okay, maybe I should just let me write it in front of it so that you see what I mean. I just put x squared there. Let me copy that and put it there. So this is how we're going to write x squared. And this other one here will be our x cubed. And for our pi, you all agree with me, pi, I'm not sure it's on the keyboard, although you can insert the symbol. Pi, let me see if I can get the symbol from here. If I go on that and then click on equations, you should be possible for me to see pi here. Let's see whether we can find it from this list. Okay, that's pi there. Let me just insert pi. So for pi, which is this one here, for pi we use something else for it, which is u, the same way, speech mark backslash u 03C0, okay, and speech mark to end. Actually, I ought to have put speech mark there. Okay, so that's a pi basically. Okay, so this is what we're going to implement, and we're going to do it very quickly. Now for square root as well, we can include square root. Let me see whether I can find square root in Microsoft Word. If I go on insert equation, oh, by the way, if I go on symbol, it should be there. Actually, pi is here. So let me go in there and see whether I will find square root. You can use the tick there basically, but let me use insert symbol and insert equation. If I go in there, I think it should be there. This is the square root symbol, as you can see here. So for my square root symbol, my square root symbol is the same way. So you type u, and then you put speech mark backslash u 221a speech mark. So we're going to be putting all these icons, and we will be including the functionalities as well. Okay, so first of all, let's implement the x squared, which is this one here. I'm just going to copy it, although I have to make modification in Python. So here we will go to button number 10, and instead of having that there, I'm just going to paste it there. Although, like I said, Python normally will not recognize the speech mark from Microsoft Word or Microsoft Excel, so we have to change that. You see, it's green now, so I'm gonna change. I have to change that as well, and that also has to be changed, and the U also maybe, and I think I'm done with that. Okay, so the next thing I'm going to do is I'm just going to copy this for the x cubed. You agree with me that the only difference is the 2, so I'm going to change the 2 to 3. So let's copy that and paste it right there, and change that 2 to 3. Okay, and for my B12, like I said, we going to be using for the square root. This is what I wrote here, u221a. So I just copy that as well. Copy that and go to my Python, and delete the 12 and replace it just like that. U speech mark. Okay. All right, and the next thing we're going to do is number 13, which I believe is the pi. The pi is UU03C0. Okay, so like I said, I don't like typing, so I'm just gonna copy that for my pi. Just go in there and type. That's B13, and then I'll paste that. Just type it there, and now let's see how these icons look like. I'm just gonna run it to see how it looks like. If I click on run, save it. Brilliant. So as you can see, I have x squared there, I have x cubed there, I have the pi there, I have the square root there. There are many more we can add. For instance, we can add bracket there as well, but I don't want to bother you with that. For now, I'm just gonna clear this and maybe make it a dot point. Okay, so for 14, let's put dot. Dot is on your keyboard. I have no need to use any Unicode. I'm just gonna put dot there, or point, decimal point. Put it this way. So if I run it now, I think we should have something. Okay, so this is brilliant. So now you can add as many functionality as you want. For instance, you can add Sigma, to find variance. You can add brackets, parentheses. You can add a lot of things you can add here. But I think you must be able to do that as an exercise. But currently they are not working. If I press x squared, you're simply just going to see x squared on the screen. If I press x squared, you see x squared on the screen. It doesn't work. S cubed, you see it on the screen. So we need to implement this by using the eval function. So I'm going to go in here and swap those codes. So I need to swap those codes. So for the x squared, instead of typing, let me just copy that and swap the x squared. Remember, the x squared is u00b2. So u00b2. I'll change this to b2, and I want this to be replaced. I want to concatenate as well, so I have to put my speech mark x, speech mark, and then plus. Okay, so this will be x squared. So I will want the x squared to be replaced with, because this is x squared, please remember x squared is exponentiation. So I'm just going to put double star 2 there. Okay, so star 2 there. So basically this we exponentiate. Exponentiation operator is double star, as you can see there. The same way you have the caret symbol for exponentiation in Microsoft Excel. For instance, if I go into Microsoft Excel now and I want to exponentiate, let's say 5 to the power of 2. Remember, in Excel, basically we use the caret symbol for that, but in Python it's slightly different. So caret symbol is used for exponentiation in Excel. So if I press enter now, it's going to tell me my answer is 25. But with Python is star. Okay, we can test this right now to see how it works. So if I run this now and exponentiate 5 to 2 and press equals, okay, there's a problem there. It says line 210 return compile integer. So let's close that. Okay, I think there is, anyway, we exponentiating x squared, so we want to replace this with sub. Do I have any error here? Okay, there's an error there. I've added a forward slash there, which shouldn't be there. I'm so sorry about that. Delete. Okay. I'm so sorry about that. So I think it should work now. Let's try it, because remember I copied the first line. I forgot to delete the forward slash for division, and that shouldn't be there actually. So it shouldn't be there. So if I type 5 squared now, you see it tells me the answer is 25 straight away. Sometimes error handling, I think I will teach you how to do error handling, so that rather than looking manually at the error, figuring out, we can handle the errors. But because you're college students, I just simply want you to understand all this step by step. Now the next one I'm going to do is the cubed. Press enter and paste. I hope you remember what I'm going to be changing here. I'm just going to change this to 3. Remember? So x cubed. So we raise it to the power of 3. Okay. And to be honest with you, you can even find what's it called? You can find cube root as well. I think I have to demo that. I don't know whether I will be able to do that. So let's run this and check whether the s cubed works. Okay, so if I type 3 cubed and press equals, it's 27. That's correct. The next one I'm going to do right now is the square root. So I will go down there, and remember, for square root there will be no need for x squared. All we need change now is the Unicode. So, and the Unicode for that is UU221A. 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 And if you are finding square root, normally you raise the number to the power of half or power of 0.5. So I'm going to put 0.5 here. Okay. And if I run this now, and let's find the square root of 9. Excellent. It gives me 3. Let's clear the screen. And square root, let me see, what other number can I find the cube root? Okay, let me put 5 times 5 times 5, which is 125. Okay, 125. Let's find the cube root of that. Excellent. It's giving me, let me see. Oh, sorry, I was cubing it. I wanted to find the square root. Let's find the square root of 144. Okay, that's correct. 12. Let's find the square root of 169. Excellent. So this works. Now the next thing I'm going to do is you probably may want to find out the Unicode for what's it called, for cube root, the symbol for cube root, the code. Let's see whether we can find this online. I'm not sure I have the code here, but you can always go online, go straight to Google, and like I told you, when you go on Google, you can search for Unicodes, characters, I put it that way, and you see list of Unicode characters. Click on that and scroll down to mathematical operators. Mathematical operators, and see whether you will find cube root. Oh, by the way, we have 1/4, we have half, vulgar fractions. Let me see whether we will see the Unicode for the Unicode. Where is the Unicode there? There are a lot of things I'm still going to show you here. Instead of writing 0.5 there, we can use Unicode for it as well. Let's see whether we will find the symbol, the Unicode for cube root. If it's not there, we can always search for it elsewhere. Cube root. Okay, that is it there. Actually, you can find the 4th root as well. Remember how I told you need to write this? This will be U221B. U221B. As you can see, this is the cube root. What I told you before, you will omit the plus. You simply just write U221. You omit the X, and this is B. U221B. So I will go back there, and instead of my decimal point, which I believe you can do on your own, I will copy the code here. Okay, and possibly just go in there and paste speech mark / U221B instead of A. That basically should put a cube root there. Let's run this. Okay, so that's the cube root there. Now, if you want to find the cube root of a number, remember this is raised to the power of 1 all over 3. Okay, so what I'm going to do there is, instead of using 0.5, let me copy that. Look at what I've written there. I wanted to write B. I will change this to 1 all over 3. 1 divided by 3. 1 divided by 3, because we're raising it to the power of 3 actually. Okay, so if I run this now, okay, so let's find the cube root. The cube root of 27, I think that should be 3. Okay, let's type 2, 7. Oh yeah, it's 9. No, is it? 9 times 9 times 9. That would be wrong. That would be wrong. In 10, 3. Oh, sorry. This basically should be 0.33333. Because remember, 1 all over 3. 1 all over 3 is 0.333. Okay. So I'll put 3333 there. You can approximate this up to 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's make it up to 8. Okay. Although it's just going to give me an approximation there. So if I type 27 now, and the cube root. Okay, this is approximately 3, which is correct. This is perfectly correct. As you can see, actually we can make this. Let's make it a little bit much more accurate. The reason is because we've used a decimal point here, and we can what can we do here? If we make it 0.4, it's going to be higher. Let's add more 3 to it, so that at least everything is much more accurate. If I put 27 there and I press cube root, press equal. Good. So that gives me 3. That gives me 3 approximately, as you can see. I hope you know exactly what I have done there. Let's multiply 2 times 2 times 2. That should give me 8. So the cube root of 8, 2. Excellent. Okay, so this is what we are learning. As you can see, to be honest with you, it's easy. The way I've developed this calculator may be different from the way other people develop their own. It is easy to expand it, to improve on it. It's open. You can add more functionality. For instance, you can add integral sign. You can add what's it called? You can add parentheses, brackets. Everything, whatever you see here, can be added. All those symbols can be added. All those icons can be added using Unicode. Even you can use the summation sign there as well. But you need to plan how you're going to evaluate it, where in the eval here, in the swapping, you need to know what to swap it with, so that during the calculation, during runtime, Python will know exactly how to evaluate the problem. Like I told you, any mathematical expression will be evaluated easily using the eval function, which is this one here. All right, and that's all. Thank you, and God bless you.